Welcome geniuses, I'm Genie, your best buddy for A-levels. In this channel, we'll bring you to explore the secret formula behind success.
For today's lesson, I'm going to teach you how to form differential equations according to the questions given. For example, in this question, there's a spherical balloon which is being inflated, has a radius r cm at the time t seconds, and it takes 3 seconds to inflate the balloon to the radius of 16 cm from the initial value of 1 cm. So in a simple model, the rate of increase of r is proportional to 1 over r squared. So you are asked to express this statement as a differential equation and find the time that it would take to inflate the balloon to a radius of 20 cm and leave your answer correct to 2 significant figures. So from here, according to the information given here, the rate of increase of r is proportional to 1 over r squared. So from here, we can actually form an equation. So the rate of increase of r is actually dr dt, given that it's proportional to 1 over r squared. So when we are changing this into an equation, you have to add in the constant of proportionality, which is the k. And in this case, it's a positive k because they mention the rate of increase. If they mention the rate of decrease, then the constant here is negative k. Alright, and then just multiply with the 1 over r squared. This is our differential equation. We'll need to solve this differential equation before we can answer the last part in this question. So to solve this differential equation, we'll just need to rearrange the variables. The r is supposed to be arranged together with the dr, where the t with the dt. So now the r squared I'll move over here to be together with the dr. As for the k, the constant k, you can choose to place it together with the dr or dt. So for me, I'll just leave it here, and the dt I'll move up here. So after we have rearranged the variables, then we'll just need to integrate both sides. So integrate r squared with respect to the r, I'll get r cubed over 3. As for the right hand side, integrate the k, we'll get kt, and add a c at the back here. So for this c, you can either put at the right hand side or at the left hand side. It's up to you, but you just need to put one c. And we are supposed to find out the value of the k and the c. In order to find out the k and the c, you got to read the information given in the question. The informations are hidden in the question. For example, now, it takes 3 seconds to inflate the balloon to a radius of 16 cm from the initial value of 1 cm, which means when t equals to 0, the radius should be equals to 1 cm. Where when the t equals to 3 seconds, the radius becomes 16 cm. So you just need to substitute these two informations into this equation, then you will get the value of the k and c. So let's try it now. Let's say now I substitute t equals 0 and r equals to 1. I'll get 1 over 3 equals to c. And if I substitute t equals 3 and r equals to 16, I'll get 16 cubed over 3 equals to k times 3 plus the c, which is a 1 over 3 that we have just found out. So from here, we can get the k is equals to 455. So after you found out the value of the k and c, you can just substitute into this general solution, and hence the answer should be r power 3 over 3 equals to the k is 455t plus the c, which is 1 over 3. So this one is called the particular solution. Where the previous one, before we have found out that the value of the k and c, is called a general solution. So after you have found out the particular solution, now you can actually answer the question. The question asks to find the time that it will take to inflate the balloon to a radius of 20 cm. So now you just need to let r equals to 20 to find out the t's value. So it will be 20 cubed over 3 equals to 455t plus 1 over 3. And hence, you will get t equals to 5.9 seconds. Correct to two significant figures as requested by the question here. That's how we form the differential equation and hence solve it. For now, I'll show you a few examples of the past year questions that requires you to form your own differential equation before you can proceed to the next part. Like for this question, have a look at the part 1 here. The question mentioned that the naturalists are managing a wildlife reserve to increase the number of plants of a rare species. The number of plants at a time t years is denoted by the n, where the n is treated as a continuous variable. So for part 1, it's given that the rate of increase of the n with respect to the t is proportional to n minus 150. And you are asked to write down a differential equation relating n, t, and a constant of proportionality. So for the part 1, it's very simple because you are asked to state this equation, the rate of increase of the n. So rate of increase of the n should be dn dt, and it's proportional to, according to the question given, is n minus 150. So you just need to write down n minus 150 here. So to form the equation, you change it into an equation by adding in the constant of proportionality here. In this case, it's a positive k because they mentioned the rate of increase, and times with n minus 150. This is for the part 1. That's how you form the differential equation. Have a look at the second example here. For the part 1, same thing. You are asked to form the differential equation. So have a look at the question. In a certain chemical process, a substance A reacts with and reduces a substance B. The masses of the A and B at the time t after the start of the process is x and y respectively, given that the dy dx is equals to negative 0.2 xy and the x is equals to 10 over 1 plus t squared. So for the part 1, you are asked to form the differential equation in terms of y and t only, and then only you need to solve this differential equation. We are not looking at the second part, but this part, the first part. You need to form a differential equation in terms of y and t only. So the differential equation given here is in terms of y, t, and the x. Let me jot down this. The dy dt here given is negative 0.2 x, y. So in this differential equation, there are 3 variables, y, t, and the x. It's impossible to solve. That's why in the question they ask you to form a differential equation in terms of y and t only. So what to do here, we will just need to substitute this x into here. Then it will be changed to 0.2 times 10 over 1 plus t square times the y with a negative, and hence we will get negative 2 over 10 plus t squared times the y. This is our differential equation in terms of y and t only. That's how we answer the first part here, and that's how we form the differential equation. Now let's apply the concept that I have taught earlier in solving this past year question. Question October-November of the year 2013, variance 31. So a diagram is given, and according to the question, a tank containing water is in the form of a cone with the vertex C. the axis is vertical and the semi-vertical angle is 60 degree here, as shown in the diagram. So when t equals to 0, the tank is full and the depth of water is h. At this instant, a tap C is open and the water begins to flow out, and the volume of the water in the tank decreases at the rate proportional to square root h. Alright, so this sentence is important to form the differential equation, where the h is the depth of the water at the time t, and the tank becomes empty when t equals to 60. So for part 1, you are asked to show that h and t satisfy this differential equation. So you are asked to prove this differential equation. According to the information given, the volume of the water in the tank decreases at the rate proportional to square root h. So from here we can actually form a differential equation for the volume. So the rate of the volume should be dv dt is proportional to square root h. And when we are changing it into an equation, we have to add in the constant of proportionality, which is k square root h. But in this question, they mentioned that the rate is actually decreasing, so we have to add in a negative to the k here. So this is our differential equation dv dt. But what is required here by the question is dh dt. So we need to link the dv dt to the dh dt here by using chain rule. Okay, so dh dt is what we need to prove. I'll just write down here. By using chain rule, it's very simple. You just need to split the dh and the dt. And what to put over here is according to the information that we have. So what we are having now is dv. So we just need to substitute the dv over here. Hence, dh dt can be found by using dh dv times dv dt. So dv dt is already found here. We can just substitute into here. But the problem is we don't have the dv dh or dh dv. So in the question given here, the volume is equals to 1 over 3 pi r square h. We are supposed to differentiate this volume with respect to the h, dv dh, to get the dh dv here. But the problem is what we are having now, there are two variables. So we got to get rid of the r here by using the triangle here. So let's form a triangle here, a right angle triangle here, and here 60 degree. So from here we can actually know that r is over here. Then by using the ratio of the right angle triangle, we can find out that tangent 60 is actually equals to r over h. So the r is equals to tangent 60 times h. So tangent 60 is equals to square root 3 and times the h. That's our r. So now what to do is substitute this r into here. Then our v will becomes 1 over 3 pi. The r is square root 3h square times the h. And hence simplify becomes 1 over 3 pi 3 h squared times the h, and hence the v is equals to pi h cubed. So now this v is in terms of h only, and hence we can find out the dv dh, which is equals to 3 pi h squared. So this is for us to sub into here, dh dv. But what we are having now is dv dh. So dh dv should be equals to 1 over 3 pi h squared. And remember, where's our dv dt? The dv dt is actually over here. Negative k square root h. Negative k square root h over here. So what they want us to prove here is in terms of a, whether a is a positive constant. So let's group the constant together. constant should be negative k over 3 pi. As for the h, this is h power half, this is h power 2, and it's divide here. So half minus 2 should be negative 3 over 2. So you notice that h power negative 3 over 2 and the h power negative 3 over 2 here is the same. We just need to change the k over 3 pi into the a. Then the part 1 can be easily proved. Part 2, you are asked to solve the differential equation given in part 1 and obtain an expression for t in terms of h and h. Alright, so according to the part 1's differential equation is dh dt equals to negative a h power negative 3 over 2. So before we can start integrating it and solve the differential equation, we have to rearrange the variables, separate the variables so that the h with the dh and t with the dt. So the h I'll just move over here, dh, and the constant negative a, I will let it be wherever it is, and the dt I'll move over here. And hence now we can integrate both sides. So for the right hand side, it becomes h power 5 over 2 times 2 over 5 equals to negative at plus c. So now we have two unknowns here, and we are supposed to find out the a and c, because the question mentioned that you can only express t in terms of h and this h only without the a and the c. So to find out the a and c, it depends on the information provided in the question. So question mentioned that at t equals to 0, the tank is full and the depth of water is h. So I jot down this: when t equals to 0, the h equals to the big H. And the other information given is over here, the last sentence. The tank becomes empty when t equals to 60. So when t equals to 60, the h becomes 0 because it becomes empty. Right, so for now, let's substitute this information into this equation to get the solution. So first, I'll substitute the first information. 2 over 5 h power 5 over 2 is equals to 0 plus c. From here, we can actually find out the c. And for the second information, 2 over 5, substitute the h as 0, will be equals to negative a times the t is 60, and the c is what we have found out here, so we can just sub into the c. Alright, so I'll have 2 over 5 h power 5 over 2 here. So from here, we try to get the a. 2 over 5 h power 5 over 2, so the a will be equals to 1 over 150 h power 5 over 2. That's how we find out the c and a. Then we'll just need to substitute both the a and c into this differential equation. So the final answer will be 2 over 5 h power 5 over 2 equals to negative a, which is negative 150 h power 5 over 2, t plus c is 2 over 5 h power 5 over 2. So this is our final answer, but according to the question, what they want is t in terms of h and the big H. So you just need to do some adjustment. What to do is bring the t term to the left hand side. So 1 over 150 h power 5 over 2 t will be equals to 2 over 5 h power 5 over 2 minus 2 over 5 h power 5 over 2. And then for every term, you just need to multiply it with 150 to get rid of the 1 over 150 here, and hence we will get this equals to 60. You can either choose to factorize the 60 or leave the 60 here in each term and remove the h here to this side. Hence we'll get 60 h power 5 over 2 minus 60 small h power 5 over 2 over the big h power 5 over 2. So you can actually leave your answer in this form, or you can simplify it into this form. That's up to you. And for the part 3, you are asked to find the time at which the depth of water reaches half big H. So for the part 3, when the H equals to half big H, what happened to the T? So what to do is you just need to substitute into here. Let me highlight this and see what happened to the T. Alright, so the T should be equals to 60 h power 5 over 2 minus 60 times half h power 5 over 2 over h power 5 over 2. And you notice that all for the upper part, the h power 5 over 2 can be factorized. So you'll be left with 60 minus 60 times half power 5 over 2 over h power 5 over 2. And these two terms can be cancelled. And then you just need to press your calculator. 60 minus 60 times half power 5 over 2. And hence the final answer should be equals to 49.4 seconds. That's how we solve for this differential equation. Let's check the answer. It's 49.4. Alright, so that's all for the lesson today. Thanks for watching.
That's all for today's video. If you're interested in more genuine sharing by other geniuses, please subscribe to our channel and don't forget to turn on the notification bell, ding dong. Also, if you're struggling with one or two past year questions and the mark scheme just doesn't seem to help, Genie has got you covered. Feel free to let us know what question it is by filling in the Google form linked in the description below. GenieUs Hub will get genius teachers to fulfill your request for the solution. Genie will see you next time. Bye-bye.